Alright, so here's the problem. You got a 1 molar hydrochloric acid solution. You only need 25 milliliters, and you need it to be diluted to 0.1 molar. So how much of the 1 molar solution do you dilute to 25 milliliters? So what we're going to do, the way I've taught you to think about it, is always start with the given amount for which you have a concentration. Okay, now we have a concentration here. We don't have an amount. We're trying to find the amount of it. We do have an amount of the 0.1 molar solution. We have 25 milliliters of the 0.1 molar solution. So I'm going to start with that 25 milliliters. I'm going to put that over 1. I'm going to convert it into liters because I know that molarity or molar concentration is in moles per liter. And I know that there are 1,000 milliliters in 1 liter. And in this class, I always want you to write that down just to remind yourself over and over again. The more times you write it, the more you remember that's where it's coming from. Conversion units always come from things that are equal. So if I put 1,000 milliliters on the bottom here and 1 liter on the top, then I can cancel out milliliters, and I successfully have the HCl solution in liters. Then I can multiply by the molar concentration of that 25 milliliters, and that molar concentration is 0.100 molar. We're going to break it out into the measurement units that make it up. In 0.100 molar, we have 0.100 moles of HCl in 1 liter of that HCl solution. Okay? I now can cancel out liters here and HCl solution. Okay? So I have it at moles. Now what I need to do to get to the volume of the second solution is to break out the beginning more concentrated solution into moles per liter and flip it. So remember that 1.00 molar, capital M, the line under it, molar HCl, is 1.00 moles, I don't know why I put a second zero on there, moles of HCl over 1 liter of HCl solution. And all we're going to do is flip it. And we're going to have 1 liter of HCl solution over 1.00 moles of HCl. So that's what I'm going to put in here. And the reason I want to do that is because now I can cancel moles by putting this on the bottom. The moles cancel. HCl cancels. We have liters of a solution. That's what I'm trying to find. How much of the 1 molar solution do I need in order to dilute it to 25 milliliters? So we just do the math now. So I get 0.0025 liters of HCl solution. Is that what you got? Oop, one thing missing. Nobody caught me yet. Huh? Sig figs. I got to have another 0 here. Need 3 significant digits. Now you can also change this into milliliters. It's easier to measure milliliters. And that would be what? 2.5 milliliters? Right? Multiply it by 1,000. Huh? Yep. So that's the same thing as 2.50 milliliters of our HCl solution. Okay? You know, milliliters are really small. That's like the end of my finger here, right? It's kind of hard to measure out 2.5 milliliters, but you can do it. I'm sorry, that's a centiliter, actually. A milliliter is way less than that. It's kind of hard to measure that out. And there are devices you can do that with. Probably have to have something called a pipette to do it, a measurement pipette. But don't worry about it. We don't use those in this class. Not a big deal. Okay, everybody got that? Now there is a shortcut to this, okay? The reason I don't teach a shortcut is this. Sometimes people have the shortcut and don't know what it means. They just plug in a bunch of stuff and hope they get the right answer. I don't want you to do that. Okay? I want you to know what it is you're trying to get to. I tell you about the shortcut. I just don't want you to use it because people throw stuff in there, and you get the wrong answer most of the time, okay? But the shortcut is concentration, molar concentration, times any kind of volume equals the second molar concentration times that volume, as long as all the units match up. The volume units have to match, and this has to be a molar concentration. And that's the problem. You got to know where it fits, okay? If you don't know how to make it fit, you won't be able to use it correctly. And there's a lot of caveats to using this. Caveats are like if and only if situation things, okay? You can use this if and only if you have molar concentration for both of these, and you have volume in the same units of measurement. Does that make sense? I'd rather you do it this way first. Then after you get used to this, well, you can use this. This is universal. This way of doing things, this dimensional analysis system, is universal. Almost universal, okay? This is not. This is like you can't use it as much as you can use this.